Kin selection, just to go over it again, is this idea that we will help each other if we're more related. Take, for example, these meerkats. Here we have mom, and we have son, and we have daughter. Mom gives her DNA to her children. She gives 50% of herself to her children, and then the father would give the other 50%. It works out that these guys would be 50% related to each other as well. So between each other, they are also 50% related. You are 50% related. You have 50% of the DNA of your brother or sister, if they're your full brother or sister. If they're your twin, you have 100%, right? Okay, so mom helps the children because the children are amplifying her DNA. They're multiplying her DNA in the world, and that is the ultimate goal of the selfish gene. And so by performing altruistic things, by helping them at the expense of her own fitness, if she decreases her fitness but increases their fitness, she still gets a fitness amplification. And that is because at 50% plus 50%, these two together equal 100% of her. And actually, she'll probably try to have a third meerkat child to increase it to 150. That is why, for example, you find that most families like to have at least 3 kids, because at 3 kids, you would amplify your DNA. And so that is why parents are so willing to go out of their way for their children, is those children are an investment. Just like investments in real life, ecology is real life, but just like investments in economics, in ecology, when we decrease our fitness temporarily, we ultimately increase it later by having children. Now, this meerkat mother would help her children, but she'd be less likely to help her nephew or her niece, and that's because she is not as related. And so we can actually see in nature when organisms are more likely to help each other. You, for example, would probably be more likely to help your brother or sister than, say, your cousin.